Stephan Schorn. Stephan's background is in structural engineering for Sixense for 6 years, doing field testing, project management, and also business management. Let's give a welcome to Stephan this morning.
Good morning, everyone. As you said, my name is Stephan Schorn. I've worked with Sixense for 6 years now. We were previously known as Advitom or Advitum. We changed our name in January because we kind of diversified our portfolio. But this morning I'm going to talk maybe only about 20 minutes, so we have some extra room for Q&A. But utilizing drones for mapping your assets and inspecting your assets. So the outline I have for today is some of the uses for drones, whether it really can help you in your line of work. Might not be useful for everyone based on the stage of your work. I'll touch a little bit on how you can use the drones to kind of set up and model your inventory, do some inspections, and I'll get into some specific projects that we've been doing here in the US and abroad. And if there is time, I'll go into just some other applications very briefly. So can drones help me, or can I use these? There's really a full spectrum of the life cycle where you can use drones, and I use the term drone loosely. It's encompassing drones, which are unmanned aerial vehicles. You can have single man operated helicopters. You can have the trucks which drive along the roadway with video cameras. So it's kind of like a digital interface to collect information about your assets, so your inventory. But here in particular, you can see that you can really use this kind of technology during multiple aspects of a bridge life cycle. You can do it during the design, you can do a pre-construction survey, during construction itself to make sure the alignments and geometry are all controlled, during operation of the bridge, for inspections and maintenance follow-up, as well as decommissioning. So you can use this technology to either replace or supplement current investigations. It's kind of the process, or the way the industry is going is really digitizing your information. Rather than doing an inspection on paper, putting it in a binder, everything is being put onto the computer. So the concept here is really just moving along that business path to provide you more useful information moving forward. Drone technology and this digital mapping can be used for multiple parts of the infrastructure and industry that we're working in, particularly the environment around your structures, the structures themselves, as well as the soils that support them. So using the drone information or the drone data, of course, you'll have your inventory of assets, the list of your bridges or what you're in charge of. You can use these to do some 2D or 3-dimensional mapping, inspections, looking for particular defects, and also you can feed all of this information into some of your models, or you can even extrapolate it for some further analysis, depending on the programs or the software you have in place. And for the different business practices that it can support, of course, it can be used for project management from the construction side or even the owner side. You can make sure everything on site is going according to plan. If the project is already complete and now you're just an owner or kind of a joint venture in charge of a concession, you can use it for asset management, again, to kind of perform your inspections, make sure everything is in line with what you're expecting. And ultimately, risk management, if you're in a densely populated area, urban center, you're doing excavation or anything like that, you can use mapping to ensure the risks are mitigated and kept under control. So what can I actually get from using drones? They can be particularly useful for, again, capturing your inventory in a digital way. Rather than having an Excel spreadsheet, you can actually have models of your inventory. So all of your bridges can be kind of pulled into this digital era. The geometric controls, again, this is really during construction or making sure alignments are properly maintained. And then performing your inspection on a detailed level, not just a visual inspection, but really using different methods like LiDAR and photography. So some of the methods that we have for collecting data, again, I said drones is kind of a loose term for me in particular, but we can use LiDAR, you can use photogrammetry, multi-beam sonar, and also video and cameras. So you can see on the left some of the vehicles for performing this type of work. We have like the airborne LiDAR, or if this is a one-man helicopter. We have drones, of course. I'd mentioned the mobile mapping. You've probably seen this a lot around the US. And of course, the sonar for boats if you need to do subaquatic investigations. So of the 3 points I mentioned for kind of the using the drones, I can elaborate a little bit more. For the inventory side, you can use them to kind of get this 3D colored point cloud, which I'll touch on a little bit more on the next slide. You can gather information about your inventory through high definition ortho images. And for the inventory purposes, you don't really need to go to such a high definition or very detailed level. So we found just a few inches is more than accurate level of accuracy here. And an ortho image, essentially if you take multiple photographs, you're taking them from different angles and you need to correct the geometry for that. So it's when you mesh them together, you're not just getting a warped panoramic view of the area. So the ortho image is really correcting those images so it's more accurate when you look at the final product. And then if you have topography of your area, you can actually integrate it into your GIS. And for geometric controls, if you have a 3D model, you compare them from one model to the next to see what changes there are. You can produce heat maps to make sure that things aren't changing unexpectedly or beyond the limits that you want. And during the inspection itself, this is where you really want those high definition images. If you're going to look at defects such as cracks or spall, you want a very high definition image. So here we go on the scale of less than 1 millimeter. And again, if you have multiple photographs, you can model them together to produce a 3D image. So for the inventory again here, once you use the drone or the helicopter to collect all of these images, you can use them to update your inventory. I know a lot of you probably already have like a bridge management system or something in place where you can pull these in to supplement or just add on to the current information that you have. And that again includes like the images themselves, which are geolocated on GPS, the 3D point cloud, and any plans you have regarding the topography. Once it's digital, it kind of just gives you an easier access to all of your information, whether it is a road, a bridge, a fence, depending on how detailed you want to go. For the 3D point cloud, these are very high density. You can do on a multiple level depending on the desired accuracy or the density you want, but 1 to 500 points per square meter. Normally we would colorize these with one of two ways. Radiometry is using the electromagnetic radiation of the objects. So it's not a true color image, but you can also do real color. So here on the lower right, you can see we used the point cloud, but then went back and put the real colors onto it, whereas on the upper center picture, it's not really the real picture, the trees aren't really orange. And at the bottom, of course, once you have all of these points, you'll want to classify them between vegetation, is it an electrical line, a building? That way you can sort through them later, and it really helps with any analysis that you're doing. For the photo or orthophotography, these are very high resolution photos. Again, if you're just doing like an inventory survey, a centimeter resolution should be fine. But when we're doing something more like inspections for cracks, you really want to get on that millimeter level. And this upper right photo gives you an example of how many photos we would have taken and then you stitch together using that geometrical correction to make sure that it produces an image which reflects what you're actually seeing visually on site. And again, these are all geo-referenced, so if you move your point of view, the picture updates automatically as though you were kind of doing a 3D view on Google Maps. You know, if you drop the person, you can see the roadway itself. So it kind of does that for your assets. So here, just a video of one of the scans we've done with some 3D point cloud, just to give you an example of a comparison here. So it's just along a roadway. We have some of the right-of-way areas for the banks and the vegetation here. So moving on from inventory to inspection, this is where we want to get a little bit more detailed. And we have some defects that we want to model, whether it's on the image themselves in a point cloud or on a 3D model that I put together. And you're able to kind of access this in a platform if you have particular software that you're going to pull it into with the 3D visualization, but it enables you to do measurements. So if you have crack widths or crack lengths, you can estimate the amount of repairs that you would need to do. Of course, you can use it to produce reports, and from year to year, if you do the exact same procedure, you can model them or compare them to each other to see if your cracks are growing, for example. So here again, just an example, if you have a topography plan, you can digitize it. So this would be more for pre-construction or during the design phase. And on the lower right, I have a model here where we've used green and red lines to model some of the cracks on the structure. For modeling, here's an example of 3D mesh. So we have, on the left, they're just silos, but we were using a drone here to take images, put it together into a 3D mesh so that they could run some finite element modeling depending on the contents of the silo. So they could model pressure and also investigate cracks from year to year. And then these are just some other models of a dam and just a neighborhood area. So here's just another example of a model that we took inside of a bridge, which gives you an example of some of the resolution that we can look at, and you can see it, I mean, it models a photograph pretty well, but we were able to turn it into a 3D representation. So this would be one instance where we could take a model from 1 year or one inspection cycle to the next, look at the crack, see if it's getting any wider or growing and creating any other concerns. Since all of this information is digital, you can pull it into, again, like your bridge management system, or if you have a 3D model that you want to use to perform your inspection, you can kind of display all of this on that model as well. Some of the benefits that I've seen, the acquisition speed is pretty good. Depending on the area, you really have to decide what the best technology to use is, if it's legal to use in that airspace. But the cost generally is a lot less than doing a manual visual inspection. I've been to a lot of rural areas, like in Canada, where they're looking at and are using our drones to do bridge inspections because bringing in maintenance of traffic, the negative platform, and all of that for a week or two just costs so much money, as opposed to bringing out 2 guys on a boat with a drone. And that's kind of a good trade-off that we've seen for some areas if it's of interest for you. So of course there are also areas that are difficult to access or not very safe for a person to access, in which case we would kind of look at or explore the options here for utilizing drones or drone technology. Again, I would like to highlight the digital aspect. If everything's moving towards digital and everything for inspections right now is printed on paper, I think there's a great benefit to collecting this all in the near future so that you can just use it going forward on your asset management plans and your financial plans. So here's an example. We're currently scheduled to do it this summer, but again, just to give you kind of like a case study, this is a bridge in Canada where they have a lot of cracks on all of their piers, and the visual inspection costs was just shooting through the roof. So they called us, and we looked at the area. We determined that it would just take 2 men on a boat for about 5 days to model, I think it's 46 piers on 2 different structures. And this one is a little bit more elaborate. This one is in France. They're building a new train route, so they're using us to do surveys before construction and then model some of the as-builts after construction of just some of the interchanges. But it's 185 miles long. It only takes about 2 to 5 days. This one we're just using the helicopter to drive along. But in the end, we estimate we'll have about 20 square miles of as-built plans of the interchanges just from these aerial images. So for that project, again, the life cycle, we're kind of being brought in to do the inventory before the construction. And then during the construction, we're going to look at some of the earth movements and then do some of the as-builts. And then in the long term, we kind of foresee that we can be used for maintenance. If you have this initial view of the construction segments, you can come back and see this isn't accurate, this wasn't there before, this is a defect that we might want to send someone out to go look at more closely. All right, I see it's only 8:19, so I'll go over some other applications real quickly. Some other markets that we've been identifying other than structural or bridge markets are like energy and nuclear for wind farms in particular, especially those over water. It's very hard to inspect those, so using drones or unmanned vehicles or even helicopters work really well for that. Oil and gas is about the same. Mining, you can have some very unsafe confined areas where you might not want to send a person, but you can send some robots or other digital means to do the inspection for you. An example for a quarry survey, and I mean, just using some software and photos, you can model the volume of the quarry, so you can very quickly see the size of what you're working with. And this works in reverse. If you have a stockpile of salt or other materials that are going up, you can use the same technology to model the volume. You can use it for looking at natural phenomena like rockfall and other environmental effects on the soils here. For overhead power lines, in some areas they are very dense, and it's not always true that the drawings or the plans that they gave you model exactly where the power lines are. And given the risk of working around those, it's probably worthwhile to know exactly where they are. So by using point clouds or images from above, we can convert them to plans that can be used by the construction firm or whatever work you're doing around there. Construction follow-up, so here are some dikes that were put in place. You can see a comparison of before and after, and then they can use it to just model how effective the work was. Again, for dams, if you want an aerial view or a 3D image of that, you can model the dam itself as well as the surrounding area. Water infrastructure, so here are some locks on canals. And lastly, for earthworks follow-up. So again, here's just an idea. If you run along the length of a construction route, you can get the profile of the earthwork that's been done, and then you can even update your plan based on the progress that's being made. So this is a more concrete way of getting a view of how your project is going rather than just kind of guesstimating your progress. Thank you, and open the floor for questions.
Two questions, actually. About midway through the presentation, you showed a slide of the interior of a pre-truss box girder.
Yep.
Could you talk about the particular equipment that you use to generate that point cloud? And also, can you briefly touch on the differences domestically and internationally on airspace requirements and kind of the legal hurdles that you have to jump through, and what like qualitatively what the differences are?
Sure. So for this particular model, we use just high resolution photography. So we sent a man into the structure with a camera, and he took a lot of pictures. And then we went and stitched them back together afterwards. So we have software that does the stitching with some manual oversight to make sure that it produces the result that you want. And then for the legal aspect, our firm has offices in the US, Canada, and Europe. And we have a lot more project in France because there is not as much oversight or legal pushback on the airspace. And we also just have a really good relationship with the French government because of our parent company. In the US, we have not yet done anything more than photography, LiDAR, things from the ground. In Canada, it's not as big of an issue, but to be honest, the one thing I've asked our legal department to provide for me is kind of like a heat map of the areas it's not really an issue and areas where it's already been approved or otherwise. I've not received that heat map yet, but I think it would be really valuable for kind of everyone to know. Because as of now, for the US projects, we kind of do a case-by-case basis. If I see an opportunity, I ask our legal department to look into it, and then they very quickly give me a summary, go, no go, or you're gonna have to wait about a year or two, it's under negotiation.
If I could add like a little bit to the answer of that question,
Yep.
we do some drone inspections, and unfortunately it seems like we're not in Type G airspace more often than not, which is the one that you can fly. You can get a COA pretty quickly from the FAA. But the new guidelines and setup that they have has kept it to about 3 months. If you need it and it's not deemed an emergency, you can usually expect a 3-month turnaround. If you need it escalated faster than that, then you need to really push your agenda to the FAA and talk to the right people.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.